So now let's talk about derivatives of natural log functions. So the derivative of natural log of x is defined to be 1 over x as long as x is greater than 0, because remember you can't take natural log of 0 or a negative number. So this is the formula for the derivative of a natural log function. So let's look at some more natural log functions here. I want you to find the following derivatives. So the first one will be the derivative of ln of 2x. So we're going to see that there's an inside and an outside, a composition. So I got to use the chain rule. So the derivative of ln of x is 1 over x, but I don't have an x here, I have a 2x. So the derivative will be 1 over 2x times the derivative of the inside. And the derivative of 2x is just going to be 2 by the power rule. So this derivative just simplifies to 1 over x. Let's look at one more. The derivative of ln of x squared plus 1. So again, we're going to use the chain rule here. The chain rule tells me I have an inside and an outside. Here's my inside. Natural log, you get 1 over. So this time it'll be 1 over x squared plus 1 times the derivative of the inside. And using the power rule, that derivative is just going to be 2x. And there's my derivative right there. Let's do one more with a natural log in it. So I want you to differentiate the function ln the square root of x plus 1. So we can rewrite our square roots, we've done this a few times, as a 1/2 power. Sorry, that should have been an x squared there. X squared to the 1/2 power. And then we can use properties of logs. Particularly, I can bring this power down in front here. So I can write, because there's this natural log function here, I can rewrite this function as 1/2 natural log of x plus 1. And now when I go to find the derivative, f prime of x, it's 1/2. And then we're going to use the chain rule for this one. Here's my inside. So 1 over x plus 1 times the derivative of the inside. And that derivative is just 1 using the power rule. So it's 1 over 2 times x plus 1. And there's my derivative right there. Okay. So let's do one more of these. And it might help if we remember these properties of natural logs. So let's remind ourselves real quick of, I'll just call this rules of logs. You can rewrite a product as an addition. You can rewrite division as subtraction. And the one we just used was ln of x to the z. You can rewrite that as z ln x. So let's look at this problem right here. Now that we remember our log rules, I want us to differentiate the function ln of x squared plus 1 squared over the square root of 2x cubed minus 1. So we could do this problem as a chain rule and then a quotient rule inside of there. But let's just use our properties of logs to rewrite this. So let's see, can I rewrite this function? It would be ln of x squared plus 1 squared minus, and I'm going to go ahead and write this denominator with a 1/2 power. This would be 2x cubed minus 1 to the 1/2. And then here I have multiplication, so I can split that up into 2 natural logs with a sum there. ln of x plus ln of x squared plus 1 squared minus a 1/2, bring out the power. And then I can also do the same thing with this power right here. So finally, in the expanded form of this function, it would look like what I have right here. And now we can take the derivative of this function, 1 over x plus 2, and then it would be 1 over x squared plus 1 times the derivative of the inside. The derivative of the inside would be 2x. Then here's my inside again, do the chain rule again. 1 over 2x cubed minus 1 times the derivative of the inside, which will be 6x squared. And there's my derivative. So don't forget that you have your rules of logs or properties of logs that might help you simplify your function and make it a little bit easier to compute derivatives.